So now I'm going to go on to part 2, where I'm going to talk about SafeML specifically. This slide shows a single diagram from a very large sample model of a robot wheelchair. So the goal of this robot is to safely convey the user around town. This one diagram shows all the safety information related to one particular hazard present when using that robot wheelchair, and includes also the functional safety features that protect against that hazard. This is the sort of view of the model that a safety engineer might use when creating the safety model. So on this next slide, I've extracted just one part of that diagram to show the safety information relating directly to the hazard itself. This shows the hazard in the top left and the harm that it may cause in the bottom left. And connecting those is what we call a harm context, which is a special association class. This harm context defines the hazardous situation or the hazardous event that has to occur for the hazard to cause harm. This is because in SafeML, hazards are always present, but harms are only caused under specific circumstances. So I'm now going to explain what I mean by all these terms such as hazards, harms, and contexts in SafeML. So first I'm going to talk about hazards. So a hazard is a potential source of harm in the system. So for example, if we have a moving car, it includes the hazard high-speed motion. And hazards are always ever present in the system. They're often inherent for the system's function. So if you look at a car, it has to move in order to be useful. That means motion hazard is always going to be present. We can't get rid of it. A harm is quite easy to understand. It is simply something that happens to injure the person or the environment. For example, if you have a car crash, then you injure the driver. That's the harm, is the injury to the driver. But how do we get from the hazard to the harm? This is where we use context, or harm context in the case of SafeML. This is the circumstances which cause people or property to be exposed to one or more hazards and therefore harm to be caused. In our example case, the context is the car crashing into a tree. So context is very, very important in SafeML. Without it, it's impossible for a hazard to cause harm. You need to have some kind of context, some kind of hazardous situation that can allow the harm to occur. So SafeML includes various elements for dealing with hazards, harms, and harm contexts. The first is the hazard element. So this is a simple element that represents a hazard in the system. This element itself usually just carries a name, but is related to various parts of the system that give rise to the hazard. For example, it can be related to requirements that, say for example, require a car to move, or it can be related to using specific components in the system. For example, if your system uses a hazardous chemical during its procedure, then this hazardous chemical will lead to a hazard in the system. These hazards sources are found during the safety analysis, and they're modeled in SafeML and SysML. The next element is the harm. This is also a simple element, merely specifying the harm that may be caused. It is not actually related to any of the elements in the system model directly, but only related to the harm, the hazard that causes it. Finally, we have the association class called the harm context. And this is a very important element in SafeML, because this is what models the relationship between a hazard and a harm that allows harm to be caused. Because it's an association class, it directly describes the relationship between one hazard and one harm. And this is important because it's always a singular relationship, in that we always have a specific hazardous situation causes a specific harm from a specific hazard. So next I'm going to talk about safety features. Safety features are features of our system that are used to provide safety. And they do this either by mitigating harm that may be caused when a hazardous situation arises, or preventing a hazardous situation from arising altogether. Other safety features are assistive in that they detect when a hazardous situation arises and then activate other safety features to mitigate harm. These safety features that directly provide safety we call defenses. And defenses are divided into two types. There are active defenses and passive defenses. Active defenses are defenses that must be activated in order to be used. So for example, the brakes of a car must be activated before they can provide safety. And passive defenses are defenses that are constantly providing safety just by existing. For example, the buffer zone at the front of a car provides safety from a collision for the driver and the passengers just by existing in the car's design. It does not require activating to be used. And this distinction between activation and non-activation is important for whether you need to have detectors which are used to decide when to activate safety features. So SafeML represents defenses using the active defense and passive defense elements. And these elements represent a safety feature in the design that is used to provide safety. Defenses are related to the harm context because rather than targeting the hazard, which is always present in the system, a defense targets a hazardous situation that allows harm to be caused, either by trying to prevent that hazardous situation from occurring or to mitigate the harm that may be caused when the hazardous situation does occur. We also have monitoring systems or detectors, and we use these to determine when we should activate active defenses. And these are very important because if you don't know when to activate your safety feature, it cannot provide safety at the critical moment. And what these do is they detect when a hazardous situation is arising, and then they activate the related active defenses. In SafeML, these are represented by the context detector element, which is related to the harm context that it detects. And so this indicates a feature that is used in the system to detect the status of the system and determine when it is in a hazardous situation. So today that's what I'm going to talk about, and next time I'm going to show you an example of producing a single diagram for a SafeML model, and I'll talk a bit about tools.